I'm Savita Valsang and welcome to my channel Statistics Made Simple. In this video, I'll find solutions to problems based on the chi-square test for independence of attributes, which are important 5 markers. Starting with the problems, the first problem, from the following data regarding the eye color of fathers and their sons, test whether father's eye color and son's eye color are independent. The table is given to us. The totals are not given. We compute the totals. So the information which is given to us are, we have father's eye color, which is divided into two classes, light and dark. Similarly, son's eye color is divided into two classes, light and dark. And the cell frequencies which are given are 230, 148, 151, 471. Now the first step is to mark father's eye color as the attribute A and the son's eye color as attribute B. The cell frequencies, that is 230 is denoted by A, 148 by B, 151 by C and 471 by D in blue color. Then we draw the two cross arrows. You can use the same color. Here I've just used two different colors for the cross arrows. The next important step is to find out the row totals and the column totals. So, if we take into consideration the column total, when we add 230 and 148, we get 378, that is A plus B. Similarly, when we add C plus D, we get 151 plus 471 equal to 622. Similarly, when I add the column cell frequencies, that is when I add A plus C, I get 230 plus 151 equal to 381, and when I add B plus D, I get 148 plus 471 equal to 619. So when we add both the row totals and both the column totals, you see that you get capital N equal to A plus B plus C plus D, which is equal to 1000. Under solution, starting with the solution, first write given capital N is equal to 1000 and alpha is equal to 5%. We can write H naught from the question. So in general, we know that H naught should be the two attributes are independent. Here the two attributes are the father's eye color and son's eye color. So H naught will be father's eye color and son's eye color are independent, versus H1 father's eye color and son's eye color are not independent. Next, write the formula. Under H0, the test statistic is chi-square equal to its capital N into AD minus BC the whole square divided by the denominator is the product of all the totals, which is A plus B into C plus D into A plus C into B plus D, and this follows chi-squared with 1 degree of freedom. Substituting the values, we get chi-square equal to 1000 into 230 into 471 minus 148 into 151 the whole square divided by, write down all the totals in the denominator, that is a product of the totals, that is 378 into 622 into 381 into 619. You will observe that if you use a scientific calculator and try to multiply all the values in the denominator, you will get a very large number and the calculations are going to become very complicated. You can try it out, and if you don't get the answer, then you can proceed in a way which I have solved the problem. So what I've done is, in the denominator, I have highlighted two totals in red color, that is 378 and 622, and the other two totals 381 and 619 I have highlighted in purple color. So in the numerator now we get 1000 into 1,08,330 minus 22,348 the whole square divided by, so I have multiplied the totals which are in red color in the denominator and then I have got 2,35,116, and when I multiply the two values in purple color in the denominator, I have got 2,35,839. Simplifying further, we get 1000 into 85,982 square divided by 2,35,116 into 2,35,839, which is equal to 1000 into, now 85,982 square I have split and written as 85,982 into 85,982, and it is divided by the denominator, which is the same like the previous step. Now if you observe, 1000 and 1 of the 85,982 and the denominator value, which is 2,35,116, I have highlighted in red color, and the remaining values, that is 85,982 and 2,35,839, I have highlighted in purple color. So when I multiply the two values in the numerator and divide it by the value which is in red color in the denominator, I will get 365.7003 into, when I divide the values in purple color, I will get 0.3646. I am doing all these steps because when we divide, the value will reduce. But if we go on multiplying, the value increases and the computations become difficult in the scientific calculator. But if you have the normal calculator, you will see that you will be able to get all the digits on the screen. So after further simplification, you will get chi-square equal to 133.33. Now the degrees of freedom for the chi-square test for independence of attributes is 1, and at 5% level of significance for 1 degree of freedom, we need K2 value, which is 3.84. Like I had already mentioned in my previous video, you can remember the value, or this value can be obtained from the statistical table. Now, the condition which is used for the chi-square test for independence of attributes is, it is a right tail test. So, you have to check if chi-square is greater than K2. If it is greater than K2, then you reject H0, otherwise you accept H0. So, the conclusion is, since chi-square is 133.33, which is greater than K2 equal to 3.84, at 5% level of significance for 1 degree of freedom, we reject H0 and conclude that father's eye color and son's eye color are not independent. Now in this particular problem, because the cell frequencies are large, you will find the calculations little tedious. But normally the cell frequencies are not large, as you will observe in the next problem, and the calculations can be done directly. 2. 46 rabbits are divided into two groups. One group, consisting of 23 rabbits, is called the experimental group, and another group consisting of 23 rabbits is called as the control group. The experimental group is not inoculated against a disease, and the control group is inoculated. Later, all rabbits of both groups are exposed to a disease. In the control group, 13 contract the disease, and in the experimental group, 8 contract the disease. Test whether inoculation and contraction of disease are independent. So, in this problem, the 2 by 2 contingency table is not given. From the given data, we have to form the 2 by 2 contingency table. Now let me first define what the term inoculation means for those who don't know. Inoculation is treating a person with a vaccine. Now read the problem very carefully. You have two groups. One is the experimental group and the other is the control group. And remember that the experimental group is not inoculated, whereas the control group is inoculated. So let us start the problem. Write given capital N is equal to 46, because totally there are 46 rabbits and these rabbits are divided into two groups. And as alpha is not mentioned in the problem, we take it as 5%. Now in the last part of the problem, they have asked us to test whether inoculation and contraction of disease are independent. That would be your H naught. So write H naught as inoculation and contraction of disease are independent versus H1 inoculation and contraction of disease are not independent. We will now form the 2 by 2 contingency table. So the first attribute A is inoculation, and inoculation, we know that you have persons who are inoculated and persons who are not inoculated. And from the information which is given to us in the problem, the control group is inoculated whereas the experimental group is not inoculated. The other attribute is contraction of disease, which is denoted by B, and you have persons who have contracted the disease and you have persons who did not contract the disease. Now, using the information which is given to us in the table, we have to form the cell frequencies, and you will see that in the table the values which are highlighted in black color are the values which are given to us in the problem, and the values which are in pink color are the values which we have calculated. Now let us see how we got the cell frequency as 13, which corresponds to the cell frequency A. Now in the problem they have mentioned that in the control group 13 contract the disease. So corresponding to the control group, that is those who are inoculated and those who have contracted, you have to write the value as 13. Then we also know that the total number of rabbits in the control group is 23. So form the column total and write 23. Similarly, they have mentioned that in the experimental group, 8 contract the disease. So for the cell corresponding to experimental group and contracted, write the value 8, which is nothing but the cell frequency C. And we also know that in the experimental group, we have 23 rabbits. So corresponding to the total of the experimental group, you can write the value 23. So 13, 23 and 8 and 23 are the only values given to us in the table. And we also know the overall rabbits, which are 46. So that also I have highlighted in black color. Let us now find out the cell frequency, which is B. So we know the overall total corresponding to the control group, which is 23. So 23 minus those who have contracted the disease, that is 13, will give us the value 10, which is the cell frequency B. Similarly, to find out the cell frequency D, it is the total corresponding to the experimental group, and from that total, which is 23, you have to subtract those who have contracted the disease. So 23 minus 8 is equal to 15. Now we need to find out the total of those who have contracted the disease. That means I have to find out what is A plus C. So 13 plus 8 is 21. Similarly, we need to find out the total of those who did not contract the disease, that is B plus D, which is equal to 10 plus 15, which is equal to 25. So when we add this 25 and 21, we will get the overall total, which is 46. The calculations are very similar to what we have learned under tabulation. Also remember to draw the cross arrows from A to D and B to C, which will help us to write the formula correctly. Under H naught, write the test statistic, that is chi-square equal to n into AD minus BC the whole square, divided by, it is the product of all the totals, which is A plus B into C plus D into A plus C into B plus D, which follows chi-square with 1 degree of freedom. So chi-square is equal to 46 into 13 into 15 minus 10 into 8 the whole square, which is divided by, write the product of all the totals, that is 23 into 23 into 21 into 25. Here the values are not as large as compared to the first problem, so the calculations can be done directly. So which is equal to 46 into 195 minus 80 the whole square divided by 2,77,725, which is equal to 46 into 115 square divided by 2,77,725, which further simplifies to 46 into 15,225 divided by 2,77,725. So we get chi-square equal to 2.1905. The degrees of freedom for the chi-square test of independence of attributes is 1. And the condition which we use to reject H naught is you have to check if chi-square is greater than K2. So at 5% level of significance for 1 degree of freedom, K2 is 3.84. So conclusion is, since chi-square is equal to 2.1095, is not greater than K2 equal to 3.84 at 5% level of significance for 1 degree of freedom, we accept H naught and conclude that inoculation and contraction of disease are independent. Problem 3. A survey of 80 voters in a constituency revealed 20% support to a political party. Another survey of 120 voters of another constituency revealed 25% support to the same political party. Test whether support for the political party in both the constituencies are independent. With the solution, let us first find out what is capital N. So if we go to the problem, we realize that there are two constituencies. I'll call them as constituency 1 and constituency 2. So capital N will be equal to the total number of voters in constituency 1 and constituency 2. So in constituency 1 there are 80 voters and in constituency 2 there are 120 voters. So totally we have capital N as 200. And again here alpha is 5%. Now they have mentioned that in the first constituency there is 20% support to a political party. So we need to find out 20% support of the total number of voters, which is 80. So it is calculated as 20 divided by 100 into 80, which is equal to 16. Similarly, in the second constituency, there is 25% support to the same political party out of 120 voters. So we have to find out 25% support of 120, which is 25 divided by 100 into 120, which is equal to 30. So this calculation is required to form the table. The question which is asked is, you have to check whether support for the political party in both the constituencies are independent. So first we will take the attribute A as support to the political party. So you will have supporters and non-supporters. Similarly, constituency, which is denoted by attribute B, are divided into two constituencies, that is constituency 1 and constituency 2. Now, with the calculations which have been carried out and with the information given, what we have to do is we have to form the column total and the column row, and we have to write capital N, which is equal to A plus B plus C plus D, which is equal to 200. Here the values which are given to us in the problem are highlighted in black color and the other calculations are denoted in pink color. So we have found out in the previous slide that in the first constituency we have 16 voters who support the political party. So corresponding to supporters and constituency 1, you write the value 16, which is the cell frequency A. Then similarly, in the second constituency, we found out that there are 30 voters who support the political party. So under supporters and constituency 2, write the value 30, which corresponds to the cell frequency B. Now when we add 16 and 30, we get A plus B equal to 46. Now the other information which is given is in constituency 1, the total number of voters are 80. That means A plus C value is already given as 80. And now we'll find out how many non-supporters are there in the first constituency, which would be 80 minus 16, that is 64, which is nothing but the cell frequency C. Also known that in the second constituency, the total number of voters are 120. That is B plus D is 120. Now 120 minus 30 equal to 90. That is the cell frequency D. So now that we have all the values, please draw the cross arrows in the 2 by 2 contingency table. Going ahead with the calculation of the test statistic, write the formula, that is chi square equal to n into AD minus BC the whole square divided by A plus B into C plus D into A plus C into B plus D, which follows chi square with 1 degree of freedom. Substituting the values from the 2 by 2 contingency table, we get chi square equal to 200 into 16 into 90 minus 30 into 64 the whole square divided by 46 into 154 into 80 into 120. The denominator is a very large value. I will not read out the calculations. So simplify and write the steps. So on further simplification, we get chi square as 0.6776. The degrees of freedom is 1 and the condition is you have to check if chi square is greater than K2. If it is, you reject H0, otherwise you accept H0. So at 5% level of significance for 1 degree of freedom, K2 is 3.84. And the conclusion, since chi square is 0.6776, this is not greater than K2 equal to 3.84. At 5% level of significance for 1 degree of freedom, we accept H0 and conclude that the support for the political party and constituencies are independent. Problem 4. From the following data, test whether literacy and smoking are independent. Use 1% level of significance. So the table is already given to us. We have to only mark the attributes and the cell frequencies, then draw the cross arrows and find out the total column and the total row. So in the table, we have literacy, which is divided into two classes, literates and illiterates. And then the other attribute is smoking, where we have two classes, smokers and non-smokers, and the cell frequencies are 18, 20, 25 and 15. So starting with the solution, Mark literacy as attribute A and smoking as attribute B. Then mark the cell frequencies A, B, C, D as I have done in blue color and draw the cross arrows. Now let's form the total column and the total row. And in the total column, you get A plus B as 18 plus 20 equal to 38, and C plus D is 25 plus 15, which is equal to 40. And when we add 38 and 40, you will get 78. Similarly, the total row, when we add A and C, you get 18 plus 25 equal to 43, and B plus D is 20 plus 15 equal to 35. And when we add 43 and 35, we get 78. So capital N is equal to A plus B plus C plus D, which is equal to 78. And the solution, right, given capital N is equal to 78 and now alpha is 1%. Then define H0, literacy and smoking are independent versus H1, literacy and smoking are not independent. The test statistic formula, chi-square equal to n into AD minus BC the whole square divided by A plus B into C plus D into A plus C into B plus D, which follows chi-square with 1 degree of freedom. Substituting the values, you get chi-square equal to 78 into 18 into 15 minus 20 into 25 the whole square divided by 38 into 40 into 43 into 35, which simplifies to 78 into 270 minus 500 square divided by 22,87,600. Simplifying further, the last step in this slide, we get chi-square equal to 41,26,200 divided by 22,87,600. So therefore, chi-square is equal to 1.8037. The degrees of freedom is 1. The condition which we use is we have to check if chi-square is greater than K2 to reject H0. At 1% level of significance for 1 degree of freedom, we know that K2 is 6.65. Now do the comparison. So the conclusion is, since chi-square is 1.8037 is not greater than K2 equal to 6.65, at 1% level of significance for 1 degree of freedom, we accept H0, conclude that literacy and smoking are independent. The fifth and final problem, problem 5. An opinion poll was conducted to find out the reaction to a proposed civic reform in 100 members of each of the two political parties. Test whether the two political parties and their reaction to a proposed civic reform are independent. Use 1% level of significance. So the table is already given to us. The political parties are party 1 and party 2, and then we have a reaction to the civic reform. So you have persons who are favoring the civic reform and those who are not favoring it. So corresponding to party 1, the cell frequencies which you have in that particular row are 40 and 60, and corresponding to party 2, the cell frequencies are 42 and 58 in that particular row. Now the first step is to mark political party as attribute A and reaction to the civic reform as attribute B. Then mark the cell frequencies 40 as A, 60 as B, 42 as C and 58 as D, and then draw the cross arrows. Next we need to find out the column total and the column row. So A plus B is 40 plus 60, which is equal to 100. Then find out C plus D, which is 42 plus 58, which is also equal to 100. So when you add 100 and 100 in the column total, you get capital N equal to 200. Then similarly, if I add A plus C, I will get 40 plus 42 equal to 82, and when I add B plus D, I'll get 60 plus 58 equal to 118. And when we add 82 and 118, we get capital N, which is equal to A plus B plus C plus D, which is equal to 200. Next, starting with the solution, write down given capital N is equal to 200 and alpha is 1%. So H naught is the political parties and reaction to a proposed civic reform are independent versus H1, political parties and reaction to a proposed civic reform are not independent. The H naught, the test statistic is chi-square equal to n into AD minus BC the whole square divided by A plus B into C plus D into A plus C into B plus D, which follows chi-squared with 1 degree of freedom. Substituting the values from the table, we get chi-square equal to 200 into 40 into 58 minus 60 into 42 the whole square divided by 100 into 100 into 82 into 118. On further simplification, we get the last step in this slide as chi-square equal to 800 divided by 9676. So we get chi-square equal to 0.0827. The degrees of freedom is 1, and by now you know the condition, that is you have to check if chi-square is greater than K2 to reject H0. So at 1% level of significance for 1 degree of freedom, K2 value is 6.65. So conclusion is since chi-square is equal to 0.0827 is not greater than K2 equal to 6.65, at 1% level of significance for 1 degree of freedom, we accept H0 and conclude that the political parties and reaction to a proposed civic reform are independent. The chi-square test on independence of attributes are important 5 markers. Do practice the concepts and the problems well. Thank you all for watching and look out for my next video where I'll explain small sample tests where n is less than 30 and explain the procedure for test for single mean.